When dealing with non-metallic building wire, or an MB cable, it's important to understand how ampacity and temperature correction work according to the National Electrical Code, or NEC. The question revolves around a 12 amp continuous load in a 50 degrees Celsius ambient environment and the correct size of an MB cable to use. The initial calculation of 12 amps times 1.25, which equals 15 amps, is correct for a continuous load, as per NEC requirements. The common practice is to then select a number 14 NMB cable and protect it with a 15 amp overcurrent protection device, or OPT, while checking for temperature correction factors. Assuming the number 14 NMB contains CHHN conductors, which have a higher temperature rating, the ampacity in the 90 degrees Celsius column is 25 amps. Multiplying 25 amps by a temperature correction factor of 0.82 for a 50 degrees Celsius ambient results in 20.5 amps. This calculation seems to indicate that a number 14 NMB protected at 15 amps would be suitable in a 50 degrees Celsius ambient. However, the crucial aspect of the code lies in section 334.80, which states that the final derated ampacity cannot exceed that for a 60 degrees Celsius rated conductor. This means even if the derated ampacity calculation results in a value higher than the 60 degrees Celsius ampacity of the conductor, you are still limited by the 60 degrees Celsius ampacity rating. For a number 14 conductor, the 60 degrees Celsius ampacity is 15 amps, as specified in section 240.4d. The key takeaway here is that you cannot protect a conductor above its 60 degrees Celsius ampacity regardless of any derating calculations. In the given example, even though the derated ampacity of the number 14 NMB is 20.5 amps, you are still limited to the 15 amp protection allowed for a number 14 conductor at 60 degrees Celsius. Therefore, using a number 14 NMB in this scenario would not be code compliant. To correctly size the conductor, you would need to use a number 12 NMB cable, which has a 60 degrees Celsius ampacity of 20 amps. This allows you to meet the requirements for the 12 amp continuous load in the 50 degrees Celsius ambient. It's important to note that some interpretations of the code can be misleading. The section 334.80 is very clear that the 60 degrees Celsius ampacity rating takes precedence. To reiterate, firstly, calculate the continuous load by multiplying the load by 1.25. Secondly, determine the appropriate conductor size based on the 60 degrees Celsius ampacity rating. Thirdly, apply any necessary temperature correction factors, but ensure the final ampacity does not exceed the 60 degrees Celsius ampacity. In summary, while the initial calculation might suggest a number 14 NMB is sufficient, the code specifically restricts the protection to the 60 degrees Celsius ampacity, necessitating the use of a number 12 NMB in this case. Always refer to the most recent edition of the NEC and consult with a qualified electrician or electrical inspector for specific applications and interpretations. Understanding the interplay between ampacity, temperature correction, and conductor protection is crucial for ensuring safe and compliant electrical installations. Remember to always prioritize safety and adhere to the NEC guidelines for conductor sizing and protection. A number 14 copper conductor has different ampacities depending on the temperature rating of the insulation. At 60 degrees Celsius, its ampacity is 15 amps. At 75 degrees Celsius, its ampacity is 20 amps. At 90 degrees Celsius, its ampacity is 25 amps. NMB cable is typically rated at 90 degrees Celsius for the conductor insulation, but the overall ampacity is limited by the 60 degrees Celsius rating due to the cable jacket. When selecting the appropriate size NMB cable, you must consider the following factors. Firstly, the continuous load. Secondly, the ambient temperature. Thirdly, the termination temperature rating of the connected equipment. For a continuous load, the NEC requires that the overcurrent protection device be rated no less than 125% of the continuous load. This is to prevent nuisance tripping of the breaker or fuse. In this case, the continuous load is 12 amps, so the overcurrent protection device must be rated no less than 12 amps times 1.25, which equals 15 amps. The ambient temperature affects the ampacity of the conductor. As the ambient temperature increases, the ampacity of the conductor decreases. This is because the conductor generates more heat at higher temperatures, and the insulation can break down if the conductor gets too hot. The NEC provides correction factors for ampacity based on ambient temperature. In this case, the ambient temperature is 50 degrees Celsius. According to NEC Table 310.15, B2. A. The correction factor for a conductor with a 90 degrees Celsius insulation rating at 50 degrees Celsius is 0.82. The termination temperature rating of the connected equipment also affects the ampacity of the conductor. The NEC requires that the conductor be terminated at a temperature that is no higher than the temperature rating of the equipment. This is to prevent the equipment from overheating and failing. In most cases, the termination temperature rating of the equipment will be 75 degrees Celsius. However, some equipment may have a lower temperature rating, such as 60 degrees Celsius. If the equipment has a lower temperature rating than the conductor, then you must use the lower temperature rating to determine the ampacity of the conductor. In this case, we will assume that the termination temperature rating of the equipment is 75 degrees Celsius. To determine the appropriate size NMB cable, we must consider all of these factors. Firstly, we must determine the minimum ampacity of the conductor. The minimum ampacity is equal to the continuous load times 1.25, which equals 15 amps. Secondly, we must apply the temperature correction factor. The temperature correction factor for a conductor with a 90 degrees Celsius insulation rating at 50 degrees Celsius is 0.82. Therefore, the derated ampacity of the conductor is equal to the ampacity of the conductor times 0.82. Thirdly, we must ensure that the derated ampacity of the conductor is greater than or equal to the minimum ampacity. In this case, the minimum ampacity is 15 amps. Therefore, the derated ampacity of the conductor must be greater than or equal to 15 amps. We can now use this information to select the appropriate size NMB cable. A number 14 NMB cable has an ampacity of 15 amps at 60 degrees Celsius. When derated for temperature, the ampacity is 25 amps times 0.82, which equals 20.5 amps. However, the NEC limits the overcurrent protection for a number 14 copper conductor to 15 amps regardless of the derated ampacity. A number 12 NMB cable has an ampacity of 20 amps at 60 degrees Celsius. When derated for temperature, the ampacity is 30 amps times 0.82, which equals 24.6 amps. The NEC allows the overcurrent protection for a number 12 copper conductor to be 20 amps. Therefore, a number 12 NMB cable is the appropriate size cable to use in this case. It is important to note that this is just a general guideline. The specific requirements for your installation may vary depending on the local electrical code and the specific equipment that you are using. Always consult with a qualified electrician to ensure that your installation meets all applicable codes and regulations. To further clarify the NEC requirements, let's delve into some specific code sections. NEC Section 310.15 outlines the allowable ampacities of insulated conductors rated up to and including 2000 volts. This section provides tables that list the ampacities of conductors based on their insulation type and temperature rating. NEC Section 240.4d provides specific overcurrent protection requirements for conductors. This section states that conductors must be protected against overcurrent in accordance with their ampacities, as specified in NEC Section 310.15. However, this section also includes some exceptions, such as the 15 amp protection limit for number 14 copper conductors. NEC Section 334.80 addresses ampacity requirements for NMB cable. This section states that the ampacity of NMB cable must be in accordance with the 60 degrees Celsius conductor ampacity, even if the individual conductors within the cable have a higher temperature rating. This is because the overall cable assembly is not rated for temperatures higher than 60 degrees Celsius. In addition to these code sections, it is also important to consider the listing and labeling requirements for NMB cable. An NMB cable must be listed and labeled by a recognized testing laboratory, such as Underwriters Laboratories or all. The listing and labeling will indicate the cable's ampacity, voltage rating, and other important information. When installing an NMB cable, it is important to follow the manufacturer's instructions and all applicable codes and regulations. This will help to ensure a safe and reliable electrical installation. Finally, remember that electrical codes and regulations are constantly evolving. It is important to stay up to date on the latest changes to ensure that your installations are always compliant. Regularly reviewing the NEC and consulting with qualified professionals can help you stay informed and avoid costly mistakes. In the specific scenario presented, the key takeaway is the limitation imposed by NEC Section 334.80. Even though the individual conductors within the NMB cable may have a higher temperature rating and the calculated derated ampacity might seem sufficient, the code mandates that the ampacity of the NMB cable is determined by the 60 degrees Celsius ampacity of the conductor size. Therefore, selecting a number 12 NMB cable with a 60 degrees Celsius ampacity of 20 amps is the correct choice for a 12 amp continuous load in a 50 degrees Celsius ambient, protected by a 15 or 20 amp overcurrent protection device. This ensures compliance with the NEC and promotes a safe and reliable electrical system. Understanding these nuances of the electrical code is essential for all electricians and electrical professionals. By carefully considering all relevant factors and consulting the appropriate code sections, you can ensure that your electrical installations are safe, compliant, and efficient. It is recommended to always refer to the latest edition of the NEC for the most up-to-date information and guidance.